Hello, this is Dr. Carroll, and this is Introductory Chemistry, 1410, at South Central Louisiana Technical College. I will begin Lecture 2. Alright, this will probably be Part 1 of 2, maybe. I'm not quite sure yet, but nevertheless, we will begin here with our second lecture. We want to discuss states of matter. Alright, states of matter. It's important that we understand, and we do understand intuitively, that we have solids, liquids, and gases. These are states of matter. And solids tend to, as we know, have defined shape. They don't change their shape very much. Actually, not at all, without a bit of energy applied. Liquids have a fixed volume, and they're hard to compress. Try to compress liquid in a small volume, you'll get quite a bit of resistance, and so its volume is pretty much fixed. And then we have gases. Now gases are highly compressible. You can get quite a bit of gas in a small space by compression, and they have neither fixed volume or shape. Of course, we all experience gases are freely flowing, and they can occupy an entire room or a very, very small space. Now, this is the initial observation. Observation meaning that before anything can really be concluded about an object, you have to observe it. And after you look at it, you want to do some experiments. And depending on what you're looking for, what you're looking at, you may have a experiment involving heat, or it might involve high pressure, or cold. It might involve applying a rigorous force or shaking. In other words, an experiment means you're taking your observation and you're testing what you see to see what will happen. I'm being very general because what I'm trying to define here are some principles that govern scientific research. Once you conclude, make some conclusions from your experiments, then you can develop what are called laws. And laws are simply a summary of the observations that you made. They may be patterns that you observe, maybe a certain kind of process that's necessary, a specific response that you get, and these define laws. Now, if these principles or this experiment can be repeated and by other persons that have an interest, then what you will do is develop a hypothesis that is founded on that law. And what a hypothesis is a tentative, that is an inconclusive, temporary, tentative conclusion or explanation. Once you have a tentative explanation, then you can come up with a theory. And a theory is based on considerable facts or evidence that explains general cause, process, causes, or principles that you've observed. Now, sometimes the kinds of observations we make, they can be one of two types: physical, or they can be chemical. All right, and physical change means that that you have the same substance or the same chemical, if you will, that simply changes form. It changes from a solid to a liquid, or from a gas to a liquid, and so forth. Those are examples. Now, chemical changes result in a transformation. Okay, we're transformation. That is, you're going from one substance to another. Okay, to another different substance. Okay, because a chemical transformation has taken place. And these are the types of things that we can observe. All right, now, these physical changes and these chemical changes are really the root to the kinds of experiments that we do. We can separate substances based on their chemical and or physical property. And a good experimenter, good researcher, would know what those chemical and physical differences are and be able to exploit that. So, what we just what I just described is a scientific method where we take our observations, we do experiments, we determine what the laws are, then we summarize these observations and develop a hypothesis or a tentative explanation which will give us a theory. And that theory has to be based on considerable facts and evidence repeated many times to give a general explanation of the cause. And our scientific method begins with the observation, either a physical or a chemical observation of change that will result in our conclusions. So, we're going to look at the atomic theory, in part 2, and I want you to keep in mind that the atomic theory was developed using the scientific method over many years.